Jai is very out of order, as in like you can define things like you can have a function that calls a function that's not even defined yet that your metaprogram inserts later at some point. And now the running of that function is what inserts a new function that then makes that function be able to continue to pass a certain step. But then it's referencing a struct, and that struct doesn't exist yet because some other function in the metaprogram is still generating that struct. So it's very, very out of order. LVM is great. Like, I hate it, but it's great that it exists.
Hello everyone, my name is Łukasz Ściga and this is the Game Engineering Podcast. This time I'm joined by Raphael Luba, an exceptional programmer with almost 30 years of experience. He worked on a multitude of projects. He co-founded Fabman HQ and is now working part-time on Jai Compiler, so the compiler of the upcoming programming language by Jonathan Blow. As you may expect, we talk a lot about this language, so if you're interested in learning about it, join us. So tell me a little bit about yourself. How did you get into programming?
That was when I was 14, so a while ago. It was right between, I was switching between schools, and one of my colleagues from the old school showed me that he programmed Hangman on a calculator. Like, he had one of those big display calculators that you could program, and he had Hangman on there, and he showed me that like right before we finished like I guess it's 8th grade or something in the US. It would be something like that. So when I was roughly 14, and I was like, whoa, you can do that? Like, you can program your calculator and have a game on there, and you typed the thing that made that do things. And I was like, okay, I have to get into that. And then we have 2 months of summer break, and so right before I started the new school, in the summer break I bought a C++ book, because I looked for something on programming in the library or in a bookshop nearby, found a C++ book, crazy expensive for a 14-year-old, but I bought it. It came with a Turbo C++ compiler on a disk.
Okay.
And just digested that book over the summer and learned all the bad it set me off in a completely wrong track, because the first thing I learned was C++, and it was very like, oh, C++ is great because of all the classes and hierarchies and like how you do all the things that C++ does, and that's how I got started. And then I started programming games when I joined the new school, and just in my spare time. Like, we were set up as a laptop class, so it was one of the first classes where we had laptops in the school. Everyone had a laptop, and I just quickly finished my assignments and then just spent the rest of the school time, when the other things people were studying, I just programmed games and whatever came to my mind.
You were provided laptops in schools?
No, we weren't provided them. We had to, like, our parents had to buy them, and then everyone had a laptop, and it was a really bad idea. Like, if we start on that topic, like, it's such a terrible idea to introduce laptops to schools. Like, don't do that. Like, people were playing, what was the thing back? I guess Counter-Strike beta was a thing back then, and whatever. Like, people were playing in the back rows and the front rows. Like, there was almost no internet. Like, there was no YouTube or something, but everyone was doing stupid stuff. No one was paying attention. I started doing my first paid contract work in school, in class. Like,
what?
What did you do? I was bored most of it. The first things were, one of the first thing was a PHP internal management application for a construction company that like does big building things, and I just management of their construction sites. And another one was a C++. I can't remember how I picked that one up. A C++ program for a Windows desktop. Like, back then, one of the things that was popular was these little. You started a program and there was a little sheep that was walking on your windows or something, and when you moved the window, it fell down and had a funny animation. Then it fell into your taskbar and moved there, and then it started climbing, and like all these kinds of little people that lived on your desktop basically. And some media company hired me to do one of those, and that was a nightmare of looking into the Windows APIs, how to figure out where the windows are and how to react to that, and how to draw transparent bitmaps on the desktop. It was well, like I knew nothing about that at that time. I just had to figure it out for the job. So things like that, all kinds of different small programming jobs.
So what have you done between that and starting your company?
A lot. Pretty much everything. I did a bunch of web stuff. I did a bunch of, well, where did I start? Good question. I never applied to a project ever. Jai was actually the first project I ever applied to. Everything else came to me by word of mouth or something, or people just knowing that I could program and asking me to do something. I did a bunch of like web tools in PHP initially. Some ASP, not ASP.NET, like old ASP stuff. For Siemens, I did a project for in ASP. I did some embedded work for a company, like contracting work for... they did fiber optic networks for live events. Like they have lots of fiber optic networks that they do ad hoc at the venue to transport all the video streams to the wherever. That was the thing back then. And they did the routing of these fiber optics networks. And they had performance problems, and they hired me and a friend to look into why their routing algorithm was taking so long and what the problem was. And that was a very interesting project. I did some more recently, I did some banking front end and banking back end stuff in Germany and Austria. I did some robotics stuff for fun. Oh yeah, we were the first autonomous sailboat, like the ASV rowboat. You can find almost nothing about it now. It was in, let me look it up. I think it was in 2006 or something. We won 3 or 4 years in a row the championship in autonomous sailing.
Autonomous sailing. You mean like you had mechanisms to attach to use sails accordingly to the wind, like?
Yeah, but it was a boat with no one on. Like it was 2006 according to the website. Yeah. So 2006 till 2010 or 2009, I was on that project and did the engineering of the visualizations and things.
I didn't know it existed. Like I am sailing. I have a sailing license. I didn't know that you can have 20 years ago already people figured out how to do it. It was
so hard back then. It was so hard. That was before like GPS and mobile computing was ubiquitous. So it was really hard to find a computer you can put on a boat and power it. And like we had to buy like some mini ITX boards with just regular desktop CPUs on it and have huge like LED batteries, like tons of huge LED batteries in the ship to power the servos and the computer. And nothing was like to get it waterproof, etc. super hard. And then you had a huge GPS antenna. Like nowadays you could just take an Android phone and put it in there and be fine. And some cheap lithium batteries. And back then it was like there was nothing. So that was hard but fun.
Okay. So how did you end up starting your own company? What does the company do as well?
Yeah, so I have like one thing I do is Fabman, which is the company you're thinking about, I guess. We're doing software and hardware for makerspaces, to manage makerspaces, and that came about because two of the guys that I did the sailboat with, the autonomous sailboat, they started a Fab Lab in Vienna, I don't know, 16 years ago or something, maybe longer by now, and they just. I knew them from school, and the Fab Lab was self-sustaining. Like they had some funding, outside funding, but basically they had to live off whatever revenue they could generate. And they just they tried to automate the hell out of it to be like, to have a chance to survive, basically, because it's hard to sustain a Fab Lab. Shall I explain what a Fab Lab is? Probably.
Yeah.
So it's basically, I usually describe it as, it's like a gym, from the business model. It's like a gym, so people become members to use your equipment, but instead of like treadmills and you have CNC mills and laser cutters and 3D printers and vinyl plotters and whatever, like heavy equipment. And so you have lots of people that come into your lab that are not super familiar with the equipment. You teach them how to use a CNC mill, and they do their projects there, and they pay you, I don't know, monthly or whatever. And so you have a problem of keeping the machine safe. That's one of the big things. Like, how do you, like, do people use the machine from time to time, but are they really like experts on it? No. So you have to make sure that people only turn on machines that they're allowed to turn on, that they know how to use, etc., etc. So basically, they try to automate all that with some, again, PHP and Arduino in in a plywood box, etc., to for some safety. But it was successful, and they survived for 10 years or something. And then people from around the world that also tried to run Fab Labs or makerspaces visited them, and they were like, "Oh, yeah, we need this system, and how do we get the system you have for managing things and keeping things safe?" And so those two guys came to me and were like, "Hey, we're trying. How can we take this PHP thing that we hacked together and give it to other people so they can run their lab?" And that's when we decided to let's take the idea, take all the things you learned, but do a fresh start, fresh platform, and make it a proper system that you can give people and that they can use to run the lab. And that's basically what we did.
Okay.
So that's how that came about. It's totally unrelated to games, totally unrelated to compilers, etc. But it taught me a bunch because I did all the engineering there, except for the actual electrical engineering. We had an electrical engineer who did the PCB designs and layouts, etc., and all the compliance stuff. But I did the firmware for the hardware that we sell. I did the back end. I did the browser thing. So
nice.
you learn.
You have such a wide variety of things you worked on,
yes,
technology-wise,
true,
but also the different
jack
systems.
of all trades, master of none.
So how and why did you apply to Jai?
I saw John's original presentation before Jai was a thing. I'm sure you've seen them. He did 2 videos, I think. I don't know when
2014.
14 were the first videos where he said, "Hey man, we need a new language for games." Yes. And that's why none of the existing ones are good. And we as an industry should come together and do something. And I watched those, were interesting. And I knew John back then from Braid. I was following his work as a designer because I loved Braid, loved the game. I don't think Witness was out by then. It was towards the ends of Witness development.
Yes, Witness was not out yet.
Yeah. But I knew John as a designer. I didn't actually know him as a good programmer or anything. I was just I was aware of him as a game designer. But I followed his work. I saw these presentations. I was like, yeah, that sounds like an interesting idea. Let's see what comes of it. And then a couple of months after those 2 videos, he was like, "You know what? I did it myself. Here's the first demo." I don't know, it was 2 months later, 3 months later, and he had a working compiler that did 50% of what the things he wanted to do. And I was like, what? And despite, I think he still used C as a backend back then. So basically his compiler just generated C code and then he ran that through C compiler. And it was so fast. The thing was, I think it was an order of magnitude faster than what I expected how fast it should be. And that blew my mind open. I was like, okay, clearly I don't know how fast computers can be because if you had asked me how fast, the fancy things he did with the metaprogramming and whatever, yeah, I was like, it's going to be slow or it should take, I don't know, that should take 3 seconds and it took half a second or something. It was an order of magnitude difference. And I was like, okay, clearly I don't know enough about how fast things can be. And clearly he does. So, and that's when he popped on onto my radar as a programmer. That does interesting stuff. And I think after the first demo, maybe after the second, I just sent him an email of hey, this looks interesting. I'm doing this and that. And I think I want this language, not for games, I don't program games, but I see it has potential as a server-side language, which was what I was mostly interested in, and as an embedded systems language. As I was fighting mediocre C++ SDKs, and I was like, oh man, that would be awesome. So I sent him, hey, great, I want to use this for other things. Whatever, let me know if I and nothing came of it because language was far from done. He did demo after demo, and I mailed him from time to time. After a demo, I was like, oh yeah, that's interesting, or my thoughts or whatever. And so we were in loose contact by then. And then he said he's going to do a first beta, and I was in the first beta. And one of the first, 12 people or whatever it was. When was that? 5 years ago, I would guess. Maybe 6 by now.
Okay.
Well, let me think. I think it must have been 5 years ago, roughly.
Okay.
And yeah, started playing with it and just was one of the beta members. And then at some point, he mentioned, I think in the Discord, that he's looking for a programmer. So that's when I applied, like, hey, this is what I do. I worked on a compiler before that. I didn't mention that. I worked on a compiler, but not in that, like, it was a transpiler actually written in C#, that was transforming a domain-specific language for business applications that a company had. And basically they had a compiler that compiled that into, I don't know what, I guess native binaries, and they lost the source code for that compiler. And they were like, we still have all these business, like this domain-driven, like this. We have all these applications written in this domain-specific language, and we can't do any updates. Like we have the compiler, kind of still works, but it can't do any changes, and we need to move it to a new platform. And so please write us like reverse. And they also like whoever wrote the compiler was
gone,
semi-available, not gone, but I was like, take these applications written in this domain-specific language, figure out what the language, like what the semantics of the language actually are, and get them to run as C# applications. That was the task.
That's such a cool task, and also like wild situation to be in as a company. Like we lost.
Oh, totally. Yeah, totally. I did that with it was a Viennese company. I was in Vienna and I had two Slovakian programmers as my helpers basically, and we tried to do that. It was a failure, honestly. Like we got it to run, but not like technically we kind of figured it out, but we were way above our heads in that one. Like I used I think it was Gold parser to generate the parser because it knew nothing about how to write a parser for that language. So I tried it with it. Like you know this, like you do these what's it called? The BNF. You do like Gold parser is like you write the BNF for your language. You know what a BNF is? No. Backus Naur form. It's a way to describe like how things are how a language is structured.
It's like grammar, formal grammar for the language.
Yeah. You do a formal grammar of the language, which was hard because we had to reverse engineer that from the programs, and then it generates a parser for you that creates the worst error messages you can imagine if something goes wrong, because it just can tell you, hey, I expected node such and such, but didn't find it, and then you can look for what's actually going on. So terrible way to write a parser. And then we took that and transformed it into C#, the result of the Gold parser, basically, and transformed it into a C# program that tried to emulate what the old thing did, which was kind of hard because it did all kinds of things that you're not allowed to do in C#. So we had to find workarounds for like making these business applications run there.
Okay.
Anyway, so that was my original compiler project that I was working on. Totally, like I told him like it's nothing like what you're doing in Jai, but that's basically my prior experience. But I did all these other things, and maybe you're interested. And yeah, that got me hired, and I've been on the project since then.
Before we dive into more like compiler level details, a lot of people who will be listening to this might like not use Jai before because it's still in closed beta. Can we paint a picture of a language in general? If you were to come and see the language for the first time, what the language is trying to do, and what are like what does it look like compared to other languages?
Yeah, I think so. The most interesting thing, I'm not going to talk about syntax because I think that's complete. I know people like to talk about braces versus brackets versus whatever, totally pointless in my opinion. But from a perspective as a programmer, it is both a very high-level language, as in I frequently use it for scripts and one-off tools and whatever, where you can just forget about memory and everything and just write things down and mostly just do high-level stuff. But it also lets you go down and affect like every bit and where every memory allocation goes to and comes from. And like it's both very high-level and super low-level, and you can, for each project or even for each part of your project, kind of choose where you want to be, which is pretty unique, because I guess like if you're God, I'm blanking on the STB
image.
What's his name? No. The STB library is by Sean Barrett.
Barrett, yeah.
If you're Sean Barrett, you can do that in C. Like you have so many utilities that you've used for decades that you can also be very high level in C, kind of. Yeah, but generally it's rare that a language gives you that. Like if you're in Go, you can be. No, actually, Go is a bad example. If you're in Python, you can be very high level, but you have no control over your memory and like layout of things and performance, honestly, mostly, unless you drop down to Python or something. If you're in C, C++, you can affect every bit and every memory allocation, but it's hard to be really high level. Of course, you can use the STL, but that's not what I'm talking about when I say high level. Like I don't want to like plug together generic algorithms to get my solution, but I want to write it down as I see it. And Jai lets me do that in a way that I haven't seen in any other language. And I've, as you've known from my introduction, like I've shipped things into production in, I counted it at one point, I think it was 12 or 14 different languages and tons of frameworks. So I've seen quite a bit. I've never seen anything that got me as excited as Jai did. And still does. Like I'm now doing projects in Go, and all the time when I'm programming Go, I was like, man, this would be better in Jai, but I can't use Jai for that project. So that's the interesting gap. Like it has a bunch of like, one of the things that's the selling point for me, this like high level and low level in one language, and you can choose at any point where you want to be, where you need to be. You can be very high level, and then once you need, I don't know, to hit some performance targets, you go really low. But I guess what other people, like what's also very unique is the metaprogramming. I guess you had John on, he talked about it.
We can dive into metaprogramming like later in terms of like deeper features of Jai. For now, like, because people might like know this from either, you can learn about Jai either watching a random stream of Jonathan Blow from like a library of like, I don't know, hundreds of hours from YouTube.
Probably,
see just couple of snapshots of him programming, or you can now Primeagen has streamed this for like a couple of hours, so we can see this. Maybe we can talk a bit what happens if you get into beta, like what do you get when you get Jai, because it's also like, I would say, quite unique experience, because like normally you just look up all the resources. Now you can ask like ChatGPT, like, you know, how do you do this in C? But in Jai it won't work. So what happens and what do you get when you get to Jai beta and you get Jai?
Yeah. Maybe one thing we should also mention, it's fast. Like one of the selling points of Jai is it's fast, like proper fast. Like it's not as fast as it could be, but already way faster than most things you're used to, which is huge as a programmer. Okay, what do you get? You get a link to a zip file that contains the compiler, obviously, and a bunch of modules. Modules is basically like small libraries that come with the compiler that give you, like, from basic string manipulation, like things you would expect from a standard library in most programming languages, but also things like ransom, how to open a rendering window and like things like that, like modules that give you from like basic things you would expect to some very game specific things. Like you have a profiler in there, you have some graphics library stuff there, you have all kinds of things, and you get an examples folder which contains some programs that John has written, like the famous invaders. If you've seen one of the early demos, what he did was to show them the metaprogramming capabilities, the compile time execution of the language. When you compile your program with this certain metaprogram, you had to play a round of invaders and you had to win to compile your program, or you had to beat a certain score or something like this. And this invaders program is in there, and a bunch of other things. And you get the how-to folder, and I guess that's what you're alluding to, which is basically a list of tutorials that explain you like how to use the language, but it's very unconventional, as in it contains lots of prose that explains the why and why nots of why certain things are not done away or how they're done, and like and it gives you an in-depth look of not just what the language does, but why it does certain things and why it doesn't do certain things and how to use it in interesting ways. And if you just read through the how-tos, which are numbered, so you can go from 1 till whatever the current number is, you get a grasp of like what the language does, and also, in a very interesting way.
And also you learn how to be a better programmer in my case, at least, because like,
True.
for example, there's like this 200 memory management how to, and it's like it starts off with like say 7 or 8 chapters of like how memory management was done before and then how it changed over years, and now use this, and now we can do this, and now it's like this is why, and after like this like prose of like I don't know how many characters or words, but you get to understand like what is the history of memory management and why now certain languages chose to do different things, and now why Jai is doing it differently.
Yeah,
I love
exactly.
it.
It's great. I really like it, and it gives you a perspective into the language designer's mind that you rarely get otherwise. But still, like even with that, most people who come to the language try to program in the style of whatever they did before. Me myself included. Like the first things I tried when I joined the Jai beta were very much not like you have to learn to let go of some things, and then like you see that whenever there's a new wave of programmers in the join the beta, you have in the questions section like all the same things, like how do I do, I don't know, X, why is there no dot chaining of calls, whatever you call that, and then people try to metaprogram the heck out of it to get back to whatever they were used to, which you kind of can in some, but it's better if you don't. But I guess the idea of the how-tos is to give you a perspective of why the language does things in a certain way and how to do that.
Yeah.
But for me, like again, it wasn't super successful. As in, I still tried to do my old ways to some extent, and had to learn to let go of that. Yeah.
And this is why you're author of like hundreds of libraries now for Jai.
Yeah, I did some. Yeah, because like, of course, if you join a new language, there's gonna be like, why is Python ubiquitous nowadays? Like, why is everyone using Python? Not because it's a great language. It's a terrible language. It's absolute like one of the worst languages in my opinion. The idea of having significant white space is a fundamentally bad idea. Like very personal. I'm not gonna go in deep into bashing, but just the idea of having white space and the kind of white space you're using be significant in how the program is interpreted is, in my opinion, a really awful idea. But apart from that, everyone's using Python. It's slow. It has some drawbacks. Why is everyone using it? You have a library that's ginormous, and you can do everything with a couple of lines because everyone has written a module that does something from like AI stuff to number crunching to, even though it's one of the worst languages for number crunching, everyone does their number crunching in Python. Not because the language is so good at it, but you have so many tools. So if you join a new language, you're going to have none of that because it's a new language. No one has written all the modules. So I was trying to do my stuff. Like as I said initially, my goal was to use it for server-side programming, which means APIs, which means you need to parse JSON, which means you need to do regular expressions to some extent for just validation, etc. So I was porting some Google regular expression library. I was trying to do a JSON parser, Postgres connection client, like all these kinds of things. I tried to build up the tools that I need to do the things in Jai that I want to do. So that's why I have a couple of them. Yeah.
So maybe we can talk about this. Jai has the ability to run arbitrary code at compile time, and then this ties into more like also metaprogramming features where you can hook up to compiler events and during compilation do some sorts of other things. Can we take some time to discuss when do you think this is useful? What you can use it for? Like what would be the ideal use cases?
Yeah. Where do we start? A very simple example. The compile time execution thing means that I quite frequently, when I do small things, I don't compile them. I just run them at compile time. Basically, I use Jai as a scripting language. The first line is run the main function, and then you don't compile the program. It just does the thing. While you compile it, actually runs and executes the thing. So that's the simplest example of what compile time execution gives you. It's minor, but like you could just have compile and run in I don't know, in your command line in one. But it's how I frequently use it. But one of the awesome things, like we have, for example, there's something that ships with the compiler is an iprof module that you can just add to the command line. Like they also use the iprof plugin, which basically means it runs at compile time and gets all the messages that get generated when you compile your program, and it uses that to automatically instrument your code for profiling. which some languages have that built in, and you can get that in various ways in all languages. But here it's just a user space thing where like someone wrote a module that can just attach to the compiler, and that automatically every function now has profiling information attached, not sampling profiling, but actually like annotated profiling, and it runs. And just this is something you can do with metaprogramming. And I did the same, like I copied that approach and made a Tracy module. Like Tracy is a popular open source compiler, visual compiler, profiler, because iProf just gives you text output, and Tracy is a like online profiler, and now you can just plug Tracy to your Chai program, and you get immediate like profiling information about your program. That's something you can do with metaprogramming, but you can do analysis. Like there's a check module that also comes with a compiler that does what, for example, C and many other languages now do, which was missing initially from C and C++, where you have a printf function and you mess up the format strings in your that don't fit what the arguments are, and that causes a lot of issues in C. So they added these warnings to the compiler. Jai doesn't have that in the compiler. It just ships with a module that does it in user space, basically. So you can have arbitrary checks that enforce your, I don't know, coding standards of, you shouldn't have a function that's longer than 10 lines or something. You can enforce this nonsense, of course, as well, with metaprograms. People use it to do all kinds of things. It's often frequently useful for generating some form of code based on your program. Like for games frequently, hey, have an enum with all the entity types you have and just enumerate them at compile time and generate the enum and put it back into your program so that it's like compiled into your program while your program is compiling. So you find all the entities during compile time and generate that enum, and then have, I don't know, create lookup functions or helper functions or whatever. For tooling assistance, like I have a small thing that I rarely use anymore, but people use it for generating Vim tags files from the compile time information.
C tags?
Yeah, C tags. Yeah.
Okay.
Things like that, whatever. All kinds of things. People do bonkers. Like if you go to there's so many people now in the beta that do way more interesting things than I ever did with it. Like people are properly trying things out, and like lots of bug reports come from that. Like we have some people who go all in on metaprogramming and generate tens of thousands of lines of generated code and like huge things, and then that stresses the compiler in interesting ways. Like I've had a couple of repros sent to us that were like, holy cow, what are people doing? But it's great. It's from a beta perspective, it's awesome because it gives you insights into where the compiler is struggling that you wouldn't get from people doing normal stuff. Yeah.
I wonder now, is Dry Beta accepting more invitations and not invitations, but like requests to access beta? Like, is it open?
I don't know. You would have to ask John. Okay. I'm not involved in that at all. Like, I got a couple of beta keys that I handed out.
Okay.
But apart from that, like, and if people ask me, like, hey, like, I get requests from time to time, and I usually forward them to John now that I'm out of keys. But I don't know. Like, this is completely in John's domain. I'm just working on the compiler, not on the management around it.
Yeah. Okay. Regarding the backend, Jai can be now compiled with like LLVM backend, right? Yeah. But also x64 directly.
Yeah, so it has its own backend. So what we're doing, so as the compiler is usually structured, as most compilers are structured, you have a front end that consists of parsing and creating a syntax tree of just the files. And then you have various phases in the compiler that end up with what in Jai is called a bytecode. So you have an internal representation of the program in a bytecode. And that bytecode is either executed at compile time, that gives it full compile time execution, or we then take that bytecode and convert it into machine code. And we can do that either via LLVM or via our own backend. And currently our own backend is just an x64 backend, so we don't have an ARM backend yet, but you could easily do that from the bytecode as well. And the x64 backend just directly generates an object file, not an executable yet, but an object file with debug information, etc. And then we pass that on to the linker. And that's way faster than using LLVM, like much faster. It's crazy how slow LLVM is. Even if it does nothing, like if you literally, you tell LLVM do nothing, like no optimizations, no nothing, it takes, I don't know, 10 times as long or something as the x64, as our backend. And that's not even doing any optimizations. But why do we have the LLVM backend? For optimizations and for targeting other platforms. Again, we only target x64 right now with our backend. If you want to target ARM, if you want to do WASM, which surprisingly many people want to do, it's interesting. And whatever, you can do that via the LLVM backend. So LLVM is great. Like I hate it, but it's great that it exists. It would be way harder to bootstrap a language without LLVM. So credit where credit is due. It's great that it exists. It's great that it's accessible and available to so many people. Like there's so many languages now, and almost none of them could exist without LLVM. So great that it exists, but holy cow. I don't want to like...
But can we dive into like not necessarily like trashing LLVM or whatever, can you explain some of those, like I heard this from Ginger Bill, who is working on Odin, hearing this from you and a couple of other people, that if you work with like LLVM closely, it's very difficult to, for example, upgrade a version of LLVM. Like a lot of things break. How is like working with LLVM? What are the pain points really? Like can you structurally honestly say?
Yeah. Like I've spent some time in the LLVM code base because I had to fix bugs there and analyze performance issues we had. And we maintain a couple of patches for LLVM that we had to write because we had issues. Upgrading LLVM, like my big issue with upgrading LLVM is not that it breaks a lot of things. That happens sometimes, but it's just, it usually gets worse from version to version. Biggest issue is performance. So generally, writing the LLVM backend, you have to, the documentation. So what's one problem with LLVM? Documentation is super sparse. Like there's almost no documentation. There's documentation of the immediate representation, which is basically what LLVM does. Like whoever uses LLVM, they're generating an immediate representation of their program in what LLVM calls the IR language, which is a very stripped down version of a language that basically all languages compile to this language and then feed that into LLVM, and LLVM turns it into, feeds it to the optimizer, etc., and then turns it into bytecode. And if you understand the immediate representation, then it's quite easy to use the LLVM API, because basically all the functions are pretty much named to generate the immediate representation tokens. I don't know, create a get element pointer, or do a store, or do a load, or whatever. I initially didn't go that route. I just tried to figure out how to use LLVM from their API, documentation API, and you're completely lost. Like it makes no sense at all. Like it's all what? But luckily someone did that work before me. So when I joined the project, the compiler, other people had worked on the compiler before. Not just John, but there were other people who have worked on the compiler from that time. And some of them figured out initially how to use LLVM, thankfully. So I had an existing LLVM backend to work on. I just improved it. But getting there from zero must have been hard. Unless you, if you know how, maybe you've done it before, or maybe you just study the Clang code base to see what they do. That might be a way. But yeah, the biggest issue that I have with LLVM is performance by far. It's crazy slow and usually gets worse for us, at least. I heard recently on a stream, someone said that no, one of the big performance gains that Rust gains from version to version is because they upgrade LLVM and it gets faster. I haven't had that experience ever. We recently did an upgrade from 16 to 17, and it was the same speed, and that was the first time that we didn't have a performance regression from upgrading LLVM. But maybe it's now better with 18 and 19. I'm going to try that relatively soon. Maybe they got faster again. One of the another issues that it's, if you do something wrong, very frequently it just hard crashes somewhere in, everything's fine. You do all the API calls and everything's fine. And then at the end you say, okay, now emit the code. And then it just crashes somewhere deep inside LLVM because you did something wrong 50 steps earlier.
Okay.
And then you have to figure out, okay, what did I do wrong that causes the crash somewhere deep down in the compiler? And it was just some function didn't get the right arguments, and there's just dies way deep inside. Like instead of failing early, it fails really late. That's one of the issues. If you do an update and they change something and you don't do the migration quite right, you didn't just have to look at that. Debug builds are unusable. That would be an issue. So you always run a release build with debug info, which of course makes it harder to debug things. But if you actually have to use a debug build, and I have to do that from time to time, it's insanely slow. It's huge. Like if you link your compiler against a debug build for LLVM, it's hundreds of megabytes big, maybe gigabytes, I can't remember. Like it's huge, and crazy slow. So you're basically always running semi-blind for these kinds of issues because you have a release build that's optimized. That would be about it. But again, it's great that it exists, don't get me wrong. And it's, if you look at the code base, it goes all in on object-oriented programming, highly abstracted, highly generic. One of the performance issues we had with updating to the new pass manager. So basically what LLVM does, you give it the immediate representation and then it feeds it through a series of stages, optimization stages, etc., and then lowers it to bytecode, to machine code. Yeah. And the pass manager is what they introduced, I think with 15 or something, which is a way of you tell it what stages to run in which order, and then it does it. And before that, they had quite a slightly different approach, and whatever. They had the new pass manager with 15 or 14. We avoided using it until we had to, which was, I think, with 16, when they removed the old one. And we immediately got 4 times as slow. Like compiling Sokoban, which is like the working title of John's next game, initially took whatever. A release build took 20 seconds, and then it suddenly took 80 or 90 seconds after the update, and we're like, what the heck? And I did a debug build, did a release with debug info build, did full profiling on it, and found the place. And it was putting for Jai, for Sokoban, it was like, I don't know, let's say 60,000 elements. It put 60,000 elements over and over and over again into a set of things to visit, one by one. Then it put it into a list of things to do something, and then it put it into a set of things that it had visited. And it did that for every function over and over and over again. And you couldn't see that, of course. Like if you're an LLVM programmer and you do your things, it looks like clean, nice code, highly abstracted. Because 3 steps down of the function you're calling, it does this over and over again, which you don't see because it's so nicely abstracted and so generic, and you just call this generic function to visit a subtree, and it just does that. And I just had to I added a patch where it just could say, don't do this for these kinds of objects so that we don't, we get our performance back. And that's what happened. Because it was of course it does the work over and over, but it's memory trashing like crazy, because it starts with a set of the default allocator allocates 32 elements, then it goes to 64, and but still it's trashing memory like crazy for every function. And these kinds of things are in there a bunch. And depending on how you use the language, you notice it or not. Like Jai used it in a special way that caused it to put 60,000 elements in there, which was an issue. If you don't do that and only put 30 in there, it's fine. But these kinds of issues you get all over the place if you have these highly abstracted, highly generic code bases. And that's one of the big issues I see.
How much time does it take to upgrade LLVM usually, comparably to other work on compiler?
It's hours, maybe a day or something, which is mostly spent waiting for compiles. So usually with every update, something changes. Like I said, the documentation is sparse. Usually you get a new version and you see the changelog, and from 16 to 17, and you have breaking changes, and you have 3 breaking changes listed, and then a to-do or something in the release notes. There's just to-do list remaining, or it's incomplete or whatever. There's nothing in there about what you actually need to do. So some of the breaking changes are in the build system. They changed something about the build system. Now you also need this sub-library to compile. LLVM takes an hour to compile. Somewhere in the middle, something fails. Whatever. These kinds of things take forever. So we have to compile it for 3 platforms right now: Linux, macOS, and Windows. And macOS we do ARM and x64, so that's 4 builds. Every build takes between 40 minutes and 1.5 hours, depending on the machine. And so this takes forever. And then you have to do figure out what they changed and applied. But that's usually minor. It's more of like getting the build system to run again, and then doing the minor, like, it depends on the upgrade, but that's about it. But whatever, very few people are going to do that. Again, the gist is LVM, it's great that it exists. It's a shame that it's written so poorly. But it's also a huge, complicated system. Like, you need a big team, probably, to do the things that LVM does. And once you have a big team, you have all these kinds of effects, usually in big projects. Like, it's not to bash LVM programmers per se. It's, I guess, it reflects the structure of its development team and of the organizations that work on LLVM, etc. So you get all these kinds of big corporate effects in there. Even though it's an open source project, like, it's backed by Apple and I don't know, Google and whoever else is working on there. So you have all these. What's the law of, like, the code reflect?
Yeah, code will reflect your team structure. I don't remember.
Yeah, exactly.
I don't remember the name though. Yeah.
Plus, you get, of course, like, all the C++ enthusiasts who did the architecture on it, and you see that. So that's. But again, great that it exists. Like, we couldn't do our work without it, and neither could, I don't know, SIG, Odin, Rust, like, all of these languages depend on it.
So let's turn to your work on Jai compiler. Can you walk me through what have you done exactly when you joined and then over the years now?
That's been a while. It's been almost 4 years now, I guess. That I've
been How much time do you work daily on compiler?
Not like I'm roughly part-time, maybe less than part-time on the project. Like, there's no full-time engineer on Jai. Never, maybe, don't say never been, but hasn't been for a while. Like, John has 10,000 things to work on, and one of them is the compiler, so he spends some time on it. And I'm, like, less than part-time on it. So what are we doing? I did some just build process improvements, general, like, doing some things there. Then I think one of my early tasks was improving the debug information, because, like, having a decent debugging experience is core to programming. I hate when I go to some ecosystem and I can't if you have to resort to printf debugging. Okay, sometimes it's useful. It's a great tool, but if you only have printf debugging and you're working on hard issues, it's not fun. So having a good step debugging experience was important. So I did a bunch of work on improving the dwarf code we output and making sure that you get all the information in the debugger that you need, and reverse engineering code view, which is, so dwarf is the debug format for Linux and Mac OS, like all Unix-based systems, and code view is Microsoft's debug information system. And code view is undocumented mostly, like, it is completely opaque. They open sourced some things on GitHub a while ago, which was great. So they documented some of their structures, etc. But the documentation was as I figured out, wrong quite often. Like, it's just plain wrong, and B, incomplete, and 3, they have now deprecated that project as far as I know. I'm not sure if there's a replacement for it, but that's the state of it. So if you want to generate debug information on Windows, you have to reverse engineer most of it. And I think I've seen your interview with Ryan. He talked about that they had on the Red Debugger team someone who did that. I did. Like, again, someone came before me on the compiler team who did the initial code view backend. Because, like, our backend, the x64 backend, has a code view and a dwarf generator, obviously, so to generate debug information. But it was missing a lot of things, and so when I improved the debug information, I had to go back into code view and reverse engineer large chunks of it, which was not fun. Especially if you have, like, I'm not sure if it's, I guess it's great to have documentation, but if it's wrong, it's...
No, it doesn't help if you have documentation.
I mean, at least it gives you some. It does help to some extent, but of course, it can also lead you astray. So you have to be very careful where you step, and if they document, I don't know, some field sizes incorrectly, and then you're, like, looking at wrong data, and it's all, like, generally debug information is hard to it's hard to gauge if something is correct initially. Like if you have some offset into some file where something should be stored, if that offsets, if the number is completely bogus, okay. But if it's slightly wrong because some bit field is slightly misdocumented or something, it takes a while to figure out what the correct thing should be, and then, yeah, whatever. So I did a bunch of like doing experiments in C and go like feeding it through MSVC and through Clang on Windows to see what it outputs, and then looking at debug output and trying to parse it. So I wrote some modules for Jai that parse PDB files, which is the final debug information file for Windows. So PDB is a crazy complicated format, contains streams of information. One of them then is the debug information in code view. It's in a simpler format in object files. So usually I quite often just parse the object files because in there you don't have to mess with PDB, just with code view. And so I did object file parsers, PDB parsers, dwarf parsers, ELF parsers, what's the COF, Common Object File Format parsers, which is COF is Windows binaries, isn't it? Man, I confuse all of these right now. It's been a while. So I did parsers for these in Jai just so I can look at which was part of the progress of figuring out how these formats work, is parse them in Jai because I like Jai, so I write these tools in Jai, and look at the output and see what I can't parse, and then figuring out what I did wrong. Just reverse engineering, whatever. And then I use that to improve the debug information we output, and also use it to. There are tools that parse dwarf for you. Like there's object dump, and I can't remember all the tools. I look them up. Like my memory, I'm old. I'm not that old, but my memory is way worse than it used to be. And I work on so many different projects that very often I can't remember the specifics. I just have a list of things like, oh, these are the commands I use to dump debug information on Linux. These are the ones I use on Windows, whatever. I think object dump is Windows actually. Whatever, can't remember. So there are tools that dump debug information in Dwarf, for example, on Linux or macOS. But if your format is broken because you're writing a compiler that outputs debug information and you mess something up, these tools just die on you, obviously.
Yeah.
So one reason why I wrote the parsers was then I can generate proper debug. Hey, this is what I expected. This is what I got. That's wrong. So I'm stopping here. And then you can find bugs because, of course, when you write debug information, you're going to have bugs in your code that generates the debug information. So if your parsers for the debug information just die when something's wrong, you don't know what went wrong. So if you have your own parsers, you can add more information about what went wrong. So that's one of the reasons why you have those parsers. What was the question?
What have you worked?
What did I do? Yeah. So lots of these things to improve the debug information. And we're pretty good at that. In some respects, there's some things we could do way better. In getting inline debug information was really hard, which means like debug information for things that were inlined functions, but also macros. Like if you have a macro call in Jai, that's basically code that's going to get inlined into your program where you called the macro, and getting the debugger to know that this was a macro that was inlined was really hard. Because there's no such concept in the debug information of macros that got inlined, because Dwarf comes from C and C++. Of course, it got extended to all kinds of other languages, but you see that the original spec for Dwarf, which is great, by the way, compared to CodeView, the Dwarf spec is really good. Like it's super detailed. It's massive document that explains everything in all variants. Like I really like the Dwarf spec. And you see that people really thought about how to express things. Like we're in Dwarf, I think we're using Dwarf 4, whatever. So it went through different iterations, and you see that things got improved and that they thought about how to do things efficiently. And like I like Dwarf. CodeView, not so much. Like there's a bunch of things where they clearly had their interns work on it. But whatever. Where was I? Sorry, got distracted by ranting.
You're still answering the question about what have you worked on, but you were doing something. You wanted to talk about like how Dwarf handles something. and then you went on
It
why.
doesn't matter. Not too important. let's.
Okay.
So that's a bunch of things I did. Yeah, inline information. That was it. Anyway, so it's hard because Dwarf doesn't know about inlining. Because it's like it knows inline functions, but the idea that you have a macro that might have some code that's from it and some code that got passed to it and that's from somewhere else, and expressing that in a debug format that has never anticipated that use case, not trivial. It's kind of okay in Dwarf. It was really hard in CodeView, especially because clearly no one tested that intensely in CodeView. Like they have functions for inline debug information, like they have structures, etc., to represent this is a function that got inlined. But since inlining usually happens in an optimized build, and in optimized builds, debug information is compromised to some extent always because there's some things that just got moved and removed and inserted, etc. It seems like no one noticed that the support for debug information for inline procedures in Visual Studio is completely broken. Like you can generate.
Seems like no one noticed.
Yeah, it seems like no one noticed because it's still in there. That if you generate certain debug information, correct debug information, completely valid debug information for inline procedures in Visual Studio, you can kill the debugger. As in, after you step over the first inline procedure, nothing works anymore. Things like that, and then you have to work around that, and so that was fun.
Okay.
Yeah. Okay. So these kinds of things. So debug information improvements. I did. I guess something that got quite popular in the beta is the bindings generator, which is not originally from me. Like there was someone who worked on the team initially did some way to generate Jai code for a C library, and that was bundled with the compiler. And then someone from the beta, I can't remember the name, but I think they're credited in the bindings generator, took that code, which was of mediocre quality, and polished it a bunch, like made it good. And then I took that again and have been improving on that for 2 years or something. So you can take a library, a C library or C++ library even, and just generate Jai code for that C++ library to call it from Jai. And it depends on the library. Sometimes it works flawlessly. Sometimes it's a pain in the rear to make it work, and I'm sorry for that. Like you have to, like there are just some things that don't transport well. There's some things we're not doing well enough, but it is a pretty good way to generate huge bindings for large libraries relatively quickly.
Yeah. So maybe let's also like for everybody who's like coming from like Python/JavaScript world or Java, like usually have like a package manager, you install it and like you don't really care about it. In C and C++, it's not doesn't work like that. There's no like standard official way of like having a package. So a lot of libraries that exist already in C and C++, you need to import them somehow. You need to make sure that like you have your own like include proper header files, and binding generator is a module that help you generate like bindings in Jai. So you have like a function in Jai which will call in fact the external function for the already compiled library in C or C++. So therefore you can like use any kind of library that exists in C and C++, generate bindings, and then use them as if it was Jai code.
Yeah, exactly. So it's basically, it's telling like what the bindings in the strictest sense do is they tell Jai how to call the original C or C++ library function. Like what is their signature? Because that's not like if you have a library, a compiled library, a lot of the information is lost on how you, like you can't just, if you give that library to any language, it doesn't know how to call that function just from the library information itself. You need additional information from the C headers, for example. Like what are the struct layouts of all the structures that get passed around? What's the type of the arguments? What's the order? What's the return value, etc. Some of that information, a lot of that information gets lost when it's compiled. So you need that information in Jai, in Python, whatever, if you want to call into those functions. And that's what the binding generator generates. And also like it's often used to generate helper functions, etc. Like if you have a function that takes C style printf arguments, but you want to have Jai style printf arguments when you call it, you can generate wrappers for that and things like that. Yeah, exactly. That's what the binding generator does.
Or sometimes convert for the bindings generator, you can do like some sort of conventions that, for example, in the original code, everything was prefixed, but you don't want to, and you now have like the ability to like modify it. So it's pretty complex and pretty cool, pretty robust.
Yeah, exactly.
Necessarily complex. Yeah.
I don't like a lot of the code in the bindings generator because it like, again, it went through someone wrote it initially, someone else took it, improved it, then I tried to improve it for years, but it never got a clean start. And it uses libclang for the C and C++ compilation. And so you're bound by what libclang gives you. We can talk about that. That's also, but I'm not sure how many people are interested in it, but it's rough. And so we use libclang to get information. And so we're kind of bound. A, it's bound by its history, and B, by libclang. So it's way more complicated than it should be, honestly. There's way more special cases, etc., than I would like to have in there. So it's a rough code base to work in, the binding generator itself. But the output is okay-ish by now. Like it depends. Some people say, amazing, I used it and it works just fine. Some people say I tried for a while and couldn't get it to work. It depends on what library you're working on, etc.
I think,
but it's been a huge help.
Yeah. Where you're coming from as well, like why I was coming from, like not necessarily C and C++ world. So this was like, okay, I need to remember now, like, okay, this is header file, this goes there, like, you know, what you need to call it. If you're familiar with that, it's like breeze probably for most people. Do you want to highlight any other things that you worked on before we move to
in Jai?
Yeah.
I did the cross-compiling support. That's something.
Okay.
Yeah. Which I'm not, like, it's still rough. Like it works. Like we're targeting a bunch of platforms. I did also. Let's stick with cross-compiling. So we can target a bunch of consoles and like compile for different platforms. And it's not that hard. Generally, like cross-compiling, like C has done it for ages and C++. Like if you're working in an embedded environment and you program, I don't know, an ESP32, whatever, you're used to cross-compiling tool chains all the time. What makes it hard in Jai, a way harder problem than I have seen before, is the compile time execution. Like Jai is compile time execution is a first-class citizen in Jai, and you can't have compile time execution by definition if you're cross-compiling. Like if you're compiling for ARM on a Windows machine, on a x64 Windows machine, like how the heck are you gonna compile time execute? Because like opening a file is something that uses completely different APIs on Windows and on Linux ARM, for example. Like everything's different. And how do you now, if you have a function for opening a file on Windows and you have one for Linux ARM, if you compile time execute it, like whatever, it's hard. In a bunch of features in Jai make it harder to cross-compile than in other languages. So that was hard to figure out. And there's some things that are still not, like, it mostly works, but if you do some compile time runs, for example, there's some special cases that are hard to explain why you have to do things a certain way to make them work properly. And I'd like to improve that, but it was a first draft to get it working. It still needs improvement. But yeah, cross-compiling was a thing. I reverse engineered, like, I'm not sure how much of that is under NDA, so I'm not going to talk about the specifics, but for a certain console, I modified our x64 backend so that it can output object files for that console directly, so we don't have to use their toolchain. You just use their linker, and you can, like, that was before we had, the problem is, of course, I can't talk about the specifics, but it was pretty awesome to get the Jai compiler to generate object files directly for a console, so you can bypass all the slow stuff and have a binary for that console within a very short amount of time. Whereas if you use their tool chain, A, you can't use Jai, and B, it's way slower. So that's something I did. All over the place. Lots of bug fixes. Lots of. I did a tracer for the compiler. So one of the issues that I have with working on a compiler and debugging it is step debugging. Often it's hard to find it's really difficult to find a place where to break, because you have, especially in Jai, you have millions of nodes that go through the compiler in different, like every node in the, like not every syntax tree node, but like Jai chunks a program in small chunks. Like every function basically goes through the compiler at its own pace. Like Jai is very out of order, as in, like, you can define things, like you can have a function that calls a function that's not even defined yet, that your metaprogram inserts later at some point. So you have to compile a program, and when you're at a certain point in the compilation, the metaprogram inserts a function into the program that's being called by other functions that already have been compiled but couldn't, like, couldn't finish compiling because you don't know the function yet because it doesn't exist yet, things like that. So Jai is very out of order. So every function flows through the compiler pipeline at its own pace. Like some things might be fully type checked and bytecode built and ready to be put into machine code, where other functions haven't even been defined yet. And so it's very hard to have in the compiler a certain point, if you want to look for a bug or a crash or something, if you set a breakpoint somewhere, you're going to hit that 1,000,000 times for different things in different orders. It's hard to find a place. Okay. It's hard to find the right place to stop and look at things if you want to debug. Okay. So for certain, so quite often you have to trace. You can think about printf debugging to a certain extent, but if you have 1,000,000 nodes and you printf debug a lot, the output is going to be a mess. So I did a tracer for the compiler, which is basically a program that runs next to it that gets via a shared memory channel, gets all the information about, hey, I found this node, this now got type checked, or this node just got inserted by the metaprogram, or hey, we now know the size of the struct, or whatever. All this information gets sent over there, and then you have a UI where you can filter like, this node with this ID, when was it type checked? When was it inserted? Was this before or after this node? Show me all the things that happened for this source line, whatever, these kinds of things. So that's a tool that I needed to find some issues in the compiler. So all over the place. Okay. Like lots of small things. John is the big architect of the language, obviously. He did most of what's in there. So I'm just nibbling at the edges and improving things. That's mostly my work. Yeah.
I don't think you give yourself enough credit, but okay. Can you walk me through the differences between Jai compiler and, let's say, like a normal compiler? Like, what would be the different things that are in Jai compiler, if there are any? Like now you said that there's like out of order. I think that's one of the things that are a bit different.
Yes.
Maybe we can start with like a kind of high-level picture of what compiler does, generally like from parsing until like getting the native code, and then contrast it to Jai.
Sure. With a big caveat, I haven't worked on any other real compiler, okay. So I can just I can tell you what I know about how Clang, etc. works, but it might be wrong. Okay. Very likely that what I'm saying is wrong. But generally, how most compilers work is like you have a parsing stage, like a lexing and parsing stage, which basically at the end of lexing and parsing, you have a syntax tree of some form. An abstract syntax tree, how it's usually called. So you have a node that says, hey, here's an addition, and this is the left side of it, and this is the right side of it, and then the left side might be, hey, this is a constant, and it's looks like an integer to me, or maybe, hopefully, and the right side is a string, or whatever. So you have a tree that represents your program, which is huge, usually, and complicated, and hard to navigate. Another issue when you work on a compiler, like, you just have chains of nodes, generic nodes, and then just having a clear picture of what's going on in the compiler when you're debugging it, just from you see a tree of nodes, it's not fun. But it's something you get used to. So you have this syntax tree after lexing and parsing. Then quite often there's some like type checking, basically making sense of the nodes, like, oh, this is a function that returns an integer, and I know what an integer is because I saw the definition of an integer somewhere earlier, or the definition of the struct or whatever. Oh, this is a struct, it contains these things. This name that it mentions, that's actually another struct, or that's a type def for an integer, or whatever. Figuring out what the meaning of a program is the type checking phase. Once you're through type checking, which finds hopefully a lot of the errors you've made while you're programming. So if the things make sense past type checking, you're ready to make an actual executable, at least, or an object file. So after type checking, there's usually an optimization phase, optional, where you try to reduce the size or complexity or whatever of the program to get it to run faster or be smaller or whatever your goals are in optimization. And then you, after optimization, you transform whatever is left, either a special syntax tree form or some bytecode form or immediate representation, into the actual machine code that the CPU then executes. And usually that machine code is then put into object files, and then you have a separate linker step, which is outside of the compiler but belongs into that ecosystem that transforms a bunch of object files into an executable, and that's where you're at. And Usually this is quite for most languages I know this is a relatively sequential thing. So you parse the things, you lex it, you parse it. So lexing means you turn characters into tokens. So you turn 3 characters back to back into an identifier token. And you take the semicolon and say, hey, this is a token and whatever. So lexing is turning strings into tokens. Parsing is, no, actually it's the other way around, whatever. Parsing is turning the tokens into trees, and then doing the things with it. And usually this is quite sequential. In Jai, it's completely out of order. Yeah? You might be, parsing is also, like for Jai, if you look at, if this is the duration of compiling a program, parsing is, lexing and parsing is over here. Like it's nothing. Yeah. And then generating the output file is somewhere here. And the rest is type checking, more or less. And in Jai, as I said, things are completely out of order, as in like you could be already executing some function that you have defined, and in that same file, some other function might still be hanging right after parsing because it's waiting for things that don't exist even yet, because the function that you're running that has already passed everything and we generate the bytecode for it and we're running it. And now the running of that function is what inserts a new function that then makes that function be able to continue to pass a certain step. But then it's referencing a struct, and that struct doesn't exist yet because some other function in the metaprogram is still generating that struct. So it's very, very out of order, which gives it its power, and it's great as a user of the language, as in like you don't have to care about header files or where things come from or in what order you declare things to most, like you don't have to care about that, but it makes it even harder for the compiler. Like it's way easier to do an in order, oh no, you have to define things before you use them, and oh no, you have to tell me from which module this thing comes from so I know where to wait on it. You can, if you import something in Jai, like import is basically, if you're from C, the include of Jai. So if you have some function somewhere in a library and you include that library into your program, you can give it a name. You can basically namespace everything in that library so that you then have to say my library dot function, and then it's clear where it's coming from. But you can also import it en masse, like everything, just put it into your own namespace and just call the function my function. And then it's Jai's job to figure out where the heck is my function coming from. Does it exist even yet? Like it might be whatever. So that's convenient as a programmer. Not so much fun for the compiler.
Okay.
So that's basically the difference. And I don't know how many other modern languages also are so highly out of order. Like if you're not having compile time execution, you can still be very much in order. The compile time execution is and the compile time redefinition or changing of functions even, etc., is what makes the out of order thing necessary. And I don't know enough about all the other modern languages to know if they have that same problem or not.
Okay. Is it fun to work with compiler?
Yes. I've worked on many projects. I've been doing this for 27 years now, roughly 26 maybe. I've never had a project that got me this excited, including my own company and my own projects. I've never been this excited to work on a project as I've been on the compiler. It's also never been this hard. Like it has the hardest, most interesting problems I've ever worked on, by a large margin.
Yeah, you need to love the challenge, I think. But then...
it's solving puzzles, but in a good way. It's not like, ooh, how do I refactor my code so that the borrow checker is happy with how I do my things? It's solving actually hard things, like how the hell do I represent our macros in the debug information formats that exist so that various debuggers can make sense of it and improve the debugger experience. Like it's actually meaningful, as in like it helps people who use a language have a way better day because they actually see things that are happening and can step over macros, etc. It's really meaningful. It's really hard, and you're really constrained by things outside of your control, as in like I can't change how dwarf or code view represents inline, like that's given. And I have to fit into that and reverse engineer, and like it's fun, it's good. It's hard.
How do you work internally in terms of, do you have like a roadmap, or like is the tasks what needs to be done is somewhat defined, or?
That's one of the very interesting and great things. I really like working with John. He's very hands off, as in he gives you, like, once he trusts you, you're pretty much like, he gives you, hey, this would be good to work on, but I'm mostly defining my own, like, I find my own things to work on mostly, unless there's like bug reports that I get forwarded or whatever. But generally it's like, this could be improved or this needs work. So I'm mostly self-directed in what I work on. And it's usually, I have a list of things that I want to work on, but as with any, like, if you're, I assume your audience are mostly game programmers. If you're working on any game, you know that this list never gets smaller. Like, it always gets bigger. Like, actually, it's on most projects. Like, your to-do list keeps growing always. Like, I've never seen a to-do list that got smaller. Maybe the individual items get smaller and they become less significant, but there's always more to add. Like, at least that's my experience. It's always more. But the things get less important. Like, you have big chunks. Once you finish one of the big chunks, you have 5 more smaller chunks that got added, and you work on 2 of those, and 10 smaller get added again, and like maybe some new big thing comes in. So I have a big list of things I want to work on, but I usually focus on like some of the most pressing things that I think are like, right now I'm really eager to get into performance improvements in the compiler, because I think there's lots of things to do better there. Not because it's slow, but because we have such a high ceiling of where we want to be. Yeah. But those are big things. Like, the things we could do, like, there's some small gains we could get. I'm going to try updating LLVM, even though that's usually a nightmare. Maybe we get something from that. But I think it's more about like thinking about how we do the syntax tree and what we can chop off there to save memory and reduce cache. Like, one of the problems with compilers and the syntax trees, it's all nodes that are loosely connected via pointers. So your cache coherence is going to be awful, god awful. And so trying to think about how to do that better is something that excites me a lot, but I'm not sure when I'm going to be able to work on that. There's a bunch of things in debug things I want to work on, like making debugging better again. So what am I working on? Things that sound, either things that are pressing, like, hey, we need to target that new console, figuring out how that works, or just making things better for the developers in the beta.
Okay. Do you feel like Jai is coming closer to the open beta now?
Yes, but I felt like that for years. So
I know. Like, I can't ask you for the release date because like you don't know and you're not in charge of that. But like, I kind of feel like now, maybe because of like Primogen stream, that's like, here's Jai, and everybody's like, okay, so what's Jai? Like, maybe because of that, feels like there's a bit of a, not like pressure, but like more awareness. And
I would refer people to your interview with John to talk about like to listen to what's there. There are 2 or 3 things in the compiler that we want to figure out before we open it wider. Like, already there are hundreds of people who have it, but make no mistake, whenever you change something about a language that hundreds of people are already using, you're causing a lot of pain. Like, if we deprecate a way of doing things or change a way of doing things, you're going to break hundreds of programs. And that's going to frustrate people. And if you do that too often, you're going to put people off. And like, screw it, I'm going back to PHP. They never change anything. Like, it's the string functions are still called what they were called in the 90s, whatever. So the bigger we make the audience for Jai, the harder it is to change things. Of course, you can be like a regular open source programmer and be just like, no, I thought of a better way to call this function. I've now renamed it and changed this is what drives me mad about the JavaScript ecosystem, is like, you have all these people who have libraries that are used by tens or hundreds of thousands of people, and they do a new major version where they change every argument to a function. Oh, no, now I'm taking an object of the argument instead of the arguments directly. Whoops, now 100,000 people have to change their code for no reason. Nothing got better. It's just, I like this more. Yeah. I wonder how many engineering hours, just personal life hours, got wasted in the JavaScript ecosystem by pointless changes to APIs. So John is very, 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 very conscious of that. Like, he doesn't want to waste people's time. He wants to give them something that works, and is so he wants to get all the big changes out of the way before we open it wider. Now we affect, I don't know, 500 people, 800 people. If you open it wider and 5,000 people use it, and you think, oh no, I want to do macros differently, whoops, every metaprogram is broken. You can't do that anymore. So there are a couple of things like metaprogramming that need an overhaul, or that John wants to do an overhaul of before we can release it. I think he talked about that a bunch. I want to do a better job of the cross-compiling. This could do an overhaul, could use an overhaul before we go out. I guess cross-compiling is a smaller use case, so it's not as big of a, if we change how cross-compiling works, we're going to affect fewer people than if we change the macro or the metaprogramming stuff. But still, that's not something I would want to change before we release.
Okay.
Yeah.
Okay. Do you have anything to add on the Jai topic before we close this? Why do you like Jai? Why do you like Jai?
It's I've never had as much fun and have never been as productive as in Jai. Speaking as someone who's written programs in C, C++, Python, ASP, PHP, C#, Ruby. Did I say Python? Probably. I don't know. Can't remember. Objective-C, Swift, Go. And I mean, not toy projects. In every single one of these languages, I've shipped things into production that have been in production for years. And I've never been as productive as in Jai, despite having lots of things not available there. I've never had as much fun. I don't know. I'm all in. I don't know. I think it's a great language. Okay. I joined the beta. I joined the again. It's the only project I ever actively applied. It's the first project I ever actively applied for, in my career. So.
Okay.
Why? Because I like it. So you shouldn't ask me. It's not perfect. There's some things that Go does better. Yeah. There's some things that I don't know. Many languages probably, but it is a combination of things. I'm super excited about it. It's of course everything's trade-offs. It's not a language for everyone. It's not a language for everything. But for the things I work on, for the things I like to program, it's by far the best tool I've seen. I'm still using other languages for other things because it's a tool. I don't understand how people can use one language for everything. If you, hey, I'm a Python programmer, I do everything in Python. Okay. Do you just have you should have more tools in your belt? You know what I mean? Jai is a pretty good tool. Yeah.
You want to have tools that are good for the job. If you're making games, you're not gonna go far with Python, right? But if you stick towards let's say one thing, and you don't really go out that often, I think it makes more sense that you're and there are a lot of people that treat this, they have a job and they want to have a life outside of job.
If you're in big corporate and all they do is Java. Oh yeah, I did a bunch of Java projects. I forgot that. Ooh, dark past. If you're just in, I don't know, if you're in banking and all they have is Java Enterprise backends, even that is changing nowadays. But if you're in banking projects, most of the backends are Java nowadays. Or okay, maybe now they use something else on the JVM, but it's a JVM. You're going to do Java and maybe some JavaScript in the front end, and that's about it. And if you're there for 10 years, you're probably going to do Java and JavaScript for 10 years. But even they might have things that need running in the ops department that are different, or things that are...
They're performant, for example, and they're still run on Fortran or COBOL.
Yeah, exactly. And they're going to crunch their numbers in the nightly batch jobs in something else, probably, maybe. Who knows? Yeah.
What tools do you use to program? IDE and other things?
So I grew up with Visual C++, don't ask me the number, probably 6, maybe before that. But I was really, I remember spending lots of time Visual C++ 6. Nowadays I've been on macOS for 18 years or something, so no Visual C++ for me. Visual Studio, as it's nowadays called. I have that when I work on the compiler on Windows, but apart from that, no. I switched to Vim very late, like 3 or 4 years ago, and I'm kind of stuck there. Ryan recently tweeted about that. Like, he gave as a life advice to young programmers: don't learn Vim, or just don't learn only Vim, because you get used, like the keys are so, like the key bindings and your gestures, etc., are so different from everything else that once you're in there, it's really hard to get out, because you're just JKLM everything in all other editors, and you just have to kind of use Vim bindings in all other editors. No, so nowadays I'm mostly in Vim. I have some things that I have to do in Visual Studio Code, unfortunately. I spend a lot of time in the Xcode debugger when I'm working on Jai, and when I work on like John's games, etc. Yeah, I have ranted enough about tools. Like, Xcode is the problem. Okay, there's a massive desert of tooling for debuggers. It's a nightmare. Like, on Windows, you have Visual Studio, which used to be an awesome debugger. It's now an okay debugger. Like, it got slower, etc., and things break more. But generally, if you're used to programming Visual Studio, you're used to just running your program, and you have the debugger already attached, and it gives you everything. Like, great experience, debugging experience. On Linux and macOS, there's nothing like it. I don't know if there's still any good UI, like good UI for Linux debuggers. I haven't found any last time I was on Linux. On macOS, you have Xcode, which is a front end for LLDB nowadays. It's slow, it's buggy. It happens frequently that they have to restart a debug session because just Xcode chokes on something and stops updating the watch window and things like that. But it's still the best UI for a debugger on macOS, which is a shame, but that's what it is. So I use Xcode for debugging because it's the only UI I know for debugging low-level stuff. Vim, Visual Studio Code. I used to do a bunch of things in Sublime. That was my editor before I switched to Vim. Now it's mostly Vim, but I don't like it. Like, I'm stuck there, kind of. I'm fast there, reasonably fast, but I'm not enjoying it. But I haven't found a good replacement.
Vim or NeoVim?
It is a NeoVim, but I use it like, I'm so to show you how little I'm interested in these things. Like, I'm not tools. Like, I use a NeoVim version nowadays. Yeah. But if you ask me what's different about NeoVim compared to Vim, I couldn't tell you much. Like, my Vim config is still in Vim script, not in whatever Lua or whatever they're using for NeoVim. Because sometimes I have to use Vim on the command line on some server, and I don't want to have two versions of my config for two different Vims or something. Like, one of the reasons why I switched to Vim was I wanted to have an editor that runs on all three platforms, and it's kind of the same, and I can use it. Like, I have to do lots of work on servers or where you just have a terminal or whatever, and I wanted to have something that works there. And then the whole point is I don't want to have a different config that I have to copy to the server or install NeoVim on the server so that I can use my Lua config or something. So I'm using it as Vim, even though it's NeoVim. That's the gist. Okay. Yeah. But it's not like, oh yeah, use Vim. It's so outdated in so many ways, it's not even funny.
Yeah, like, I feel like a lot of people that are just like programming on Linux and OS X, they're not interested in debuggers because they were never part of the toolchain really, like natively with the ecosystem. And for example, NeoVim is like, or Vim are super cool programs because like you're mostly doing printf debugging, and if you like switch and if you ever develop something on Windows, especially with like Visual Studio, you're kind of used to it. If you ever developed a game, either even like in Unity or like Unreal, you're used to like launching Unreal already into the debug mode, so that like whenever something happens, you can stop. And
exactly,
because like state is not easy to reproduce. And there's so many differences between the platforms, and people say like, oh, it doesn't matter, you can use this platform, that platform. It's like,
no.
it's such an ecosystem. Like,
Yeah.
mentality is different already.
Yeah, very much. And I don't understand, like, Ryan goes on about this on Twitter a bunch. I don't understand people who are just using printf debugging. Like, I guess it's if you're from a platform, again, if you're from a platform where there's no good step debugger, of course you're using printf debugger because you have nothing else. But it's such a game changer. It's just something goes wrong and you just set a breakpoint somewhere or set a watch point on a memory address. And like, when this changes, I want to know where it happened and why. You can't do that with, like, doing printf debugging on a game is gonna wreck your brain. Like, there's no way you're gonna do anything. So yeah, that's having a good, like, and that's why I'm so excited about Red Debugger. I was excited about Remedy first. I bought it. I tried to use it a bunch of times. I used it a bunch of times, but it was still lacking in many things. And now I guess Red Debugger has superseded that. I'm so looking forward to going to having a macOS version of that. That's, yeah, I hope I don't have to use Xcode again once that happens.
So let's close out with this one. What would you say as an advice for people that start to learn programming now? They are surrounded, I would say, by a lot of weird advice on the internet that mostly focus on how their code looks like, in terms of like how to structure abstraction, things like that. What would you say? Like, where to pay attention?
Yeah, that's a hard one. I learned to program 28 years ago. So I'm the wrong guy to ask how to learn it nowadays because everything's different. Like, I had to buy books, like hardcover books, to learn how to use a language. Like, nowadays you ask ChatGPT and get a broken answer, but whatever. It's completely different. So I can't give you advice on that. Do you know Jason Fried? He's one of the founders of 37 Signals / Basecamp. He's a good guy to follow generally. Like,
Okay.
Not as a gaming engineer, like he's a designer and product guy, but he thinks about things and in a good way. But he often said, like, people ask him like how to start a company, and like he's like, I don't know, I haven't started a company in 20 years or something. I'm the wrong guy. Ask someone who started a company 3 years ago, because I can tell you how to run a company for 20 years, but not how to start one, because everything's different now. Same for me. I can't tell you how to start programming because I haven't done it in over 20 years, 25 years. It's very different now. Ask someone who recently learned to program. Ask someone who did it for 3 years how they learned it. Maybe that's better. I can tell you what not to do. Don't listen to the people online. That would be my advice, because like I got poisoned by a C++ bug, but it's way worse, or by the clean. Oh God, I totally adopted the clean code mentality for 2 or 3 years and did a lot of damage in that time. Like I still think about that and I'm sorry for it. Don't buy what people are telling you about how to write code, because most people are wrong. Myself included, probably. I still, like, to this day, if I look back at code that I've written 5 years ago, and it's been like that every year since I've started to learn program, I look at my code that I've written a couple of years earlier, and I'm like, oh my God, I knew nothing. What was I doing? Oh my God. And I've had that for probably 20 years, almost every year that I look back. So I'm pretty sure if I look back on my code that I've written last year in 2 years, I'm going to be, holy cow, like, you could have done this so much better. Why, like, who was that idiot? So maybe you shouldn't take advice from me either. It's no, I'm serious. I'm really serious. Like, the things I think are good now might change in a year or two, because hopefully I get better still. It's definitely, don't listen, because the people who have time, like, that's one of the problems we have. The people who have time to write about and talk about how to program are by definition not spending that time programming. The more time they spend advocating for things and talking about things and teaching things, the less time they spend actually doing the thing. And that's a problem, because you have a bunch of people who are giving talk after talk about how microservices are awesome, and I'm not sure how to end that sentence in a kind way. So the problem is, the people who talk about how to do things are like you see that in university a bunch. The people who teach, at least that's my experience in university, the people who teach people how to program at university have never, usually, I've never seen one, spend lots of time compiling and working on and improving and changing a program for a long time, because the things they teach you don't work in these kinds of scenarios. They work on toy projects. I work on this for 6 months or a semester or something, and then I toss it away and I work on the next thing for the 6 months. It doesn't matter how you do it. You can do it. But if you have to maintain something for 10 years and react to changing environments and keep improving it and update it for changing platforms, whatever, you learn what works and doesn't work, hopefully. And it's not what people teach you usually. That's my experience. So listen to Casey. Like there are a couple of gems out there, but how do you find them? Like there are so many people who scream so much louder than Casey or John or Carmack or and you have to find them in the ginormous universe of JavaScript people who have done things for 3 months and thought they know how to redesign the build system, and now you have another iteration of whatever. Like I don't know if you follow the web ecosystem or if it's the audience of your podcast, but the web is a great example of people who don't know the history of the thing they're working on, because they keep reinventing the same solutions. No, it's cyclic. It's crazy there. Like when I started doing lots of web, I don't know, like intensely the modern web stuff, I don't know, 12 years ago or something, you had, what was the initial one? Grunt, I think, was the initial build system, which was, let me try to I probably get the history wrong, but the gist is you had a build system for JavaScript that was imperative. Like you just write JavaScript code for that builds your JavaScript program. And people were like, oh no, imperative is so stupid. Let's do it declarative. And they did a declarative build system. I think Grunt was the declarative one, and before that was whatever. So you have a declarative approach, and then like, oh wait, declarative doesn't work for all the special cases. So you have lots of kind of programming in a declarative language, and people are, that's so stupid. Let's do it imperative language. And you have Gulp, and Gulp is the imperative, and then Gulp is done for a while, and people are like, oh my god, Gulp is so stupid, let's do it declarative again. And then you have just scripts in your package JSON, and people are like, wait, that's kind of and you keep having, oh, let's do Webpack. Webpack was declarative again. So you no, it's they keep making the same mistakes every 2-3 years when a new wave of new programmers comes in, and don't learn what people have done in the past. That would be my advice. So learn what didn't work. Try to avoid that. Try to avoid making the mistakes that people have done before you. But how to do that nowadays, I have no idea. I'm sorry, I'm so far gone from that kind of thing. Yeah. Okay. That's pretty much. Okay. Just follow Casey, I guess. Follow Casey is the best advice I can give.
I mean, Handmade Hero and also computerenhanced.com. Right.
Yeah, exactly. I've been a subscriber to Computer Enhanced since the start. I haven't had time to follow the actual courses, but I think it's still like money well invested. I think I did the first, whatever you call it, season, chapter, whatever, maybe a bit more.
Yeah, I've done almost all of it, and it taught me a lot about like how to think about CPU, like processor.
Yeah.
Like your program will not live in a vacuum. Like it matters how you do things, and like how really it works. Like you build up the CPU software version of like a CPU, and then you actually interact with it and see how instructions flow and like all sorts of things that are really like I wouldn't think about before.
Which might, like, doing this, it might sound crazy. Like if you're from enterprise Java world and you think like, what are you learning? That should make sense. It makes sense to do that, even if you're like the senior Java engineer in a, oh God, what are they using nowadays? Maybe Spring Boot, or maybe they're still in Java Enterprise. I don't know. Even then, it makes sense to think about what the CPU is actually doing, or maybe learn what the JVM is actually doing. What does the JVM, what does it do? Like, what does your JVM instructions look like when you do something? and then think about what that does to because you think it's not necessary to think about memory but there's a reason why your company had to buy the $12,000 server and it still runs like crap. Like, there's a reason why that's the case. And there's a reason why your Google Cloud bill is $120,000 when it could be a single machine under your desktop. Like, there's a reason for that. And it's good to learn where you can still say, like, once you've learned that, you can still say, doesn't matter, it's worth it. Like, I'd rather pay $120,000 for Google Cloud than spend 3 more engineers to do it lower. Okay, but then it's an informed decision. Like, there's no solution. There's this, who is it? Is it Thomas Sowell who said there's no solutions, only trade-offs? Like, that's true 100%. Don't believe people who say there's a solution it's all trade-offs, but you have to know the trade-offs you're making. Like, if you use Python for something, that's what Casey's course is great. Like, he says there's a good reason. Like, when he did his initial, like, showing how slow Python is, it was not a don't use Python. It was a be informed about what you're doing, know the trade-offs you're making, and then make the trade-offs, but know what you're discarding when you make the trade-offs. You can still say, no, it's totally right for us to write things in Java and not care about anything, but know that this means your server costs are through the roof and things are slow, but maybe that's fine for you because you don't care, but you only have 3 engineers and they're faster in Java, do it, but you have to know what you're doing.
Thank you so much for joining me, discussing a lot of Joy compiler insider things and a lot of other things software related. Thank you so much, Raphael.
Thanks for having me. It was a lot of fun. I wish you all the best for your podcast in the future as well.
Thank you so much for listening to this episode of the Game Engineering Podcast. Don't forget to subscribe on YouTube and follow on Spotify and other podcasting platforms. See you in the next episode.